last video we showed that the difference in potential between 2 points, when you evaluate it by this path integral, the answer doesn't depend on the path at all. So let's try to just see intuitively how this integral doesn't depend on the path. So let's cut up the path into small parts. So this is dr1, the element of length from point C1 to point C2. And at the same thing, we have an element of length from here to here, and here to here, and here to here. Of course, as we have said, that there are infinite number of elements of length, but let's just do 1, 2, 3, 4, so we could just illustrate the idea. So we know the rule for the difference in potential between 2 points that are very close. For point C and 1, when C2 and C1, when they're very close, V at C2 minus V at C1, it's just minus E dot dr. This was the rule that we got for the difference in potential between 2 points that are very close. What if you get the difference in potential VC3 minus VC2? Well, it's just minus E at C2 dot dr2. What's the potential at C4 minus C3? It's minus the electric field at C3 dot dr3. The potential at 5 minus 4. It's minus the electric field at 4 dot dr4. So now when you add all these things up, of course, as I mentioned, you have not just 4 terms, you have an infinite number of terms, but look and see what happens when you do the addition. You have here VC2 minus VC2, it's gone. VC3 minus VC3, it's gone. VC4 minus VC4, it's gone. The only thing that will survive on the right-hand side is the potential at point C5, which is the potential at the final point 2, minus the potential at the initial point C1, which is the point over here. So when you add up all these difference in potentials as you go along the path, you just end up with the potential at the final location minus the initial location. And then what is that potential then? The potential at 2 minus 1, it's equal to the sum of all this, which is the path integral. So the path integral, it turns out to only be depending on the value of the potential at the final point minus the value of the potential at the initial point, not on a particular path. And so that's basically kind of the idea of how you can intuitively see why this integration doesn't depend on the particular path.